Okay, guys, in this example, let's look at testing the population proportion using Desmos graphing calculator. The first thing we will do is compute a point estimate for the population proportion. I hope you remember that the population proportion is denoted by P and sample proportion is denoted by P with the hat on top. And point estimate means sample proportion, p hat. And I also hope that on your note cards you have a formula for the p hat, which is just a proportion x divided by n. Let's go ahead and compute that using Desmos. We're going to click on resources, go to the Desmos graphing calculator, and let's see if we can figure out what is x and what is n. It says roughly 8% of all bachelor's degrees were in education in the past, but now we think this percentage has declined. We found that in a sample of 1,600 college graduates, 90 of them graduated with a degree in education. Which of these two numbers, 90 and 1,600, is x and which is n? So remember, x is the number of trials and n is the number x is the number of successes and n is the number of trials. I think I confused you. Okay, so x should always be less than n. And so we're going to just divide 90 divided by 1,600 to get the sample proportion p hat. We do need to round this to 4 decimal places. Let's do a comma 4. Okay, that's my p hat. The next thing is to decide what's going to be our hypothesis. Now, hopefully you already realize that this is going to be proportion, and proportion means P. But if you don't remember, is it P or P hat, which hopefully you remember that you never put anything from the sample into the null or alternative, and both of these should be P. But if not, then just click on the inference menu, go to the test for proportions. Again, you should know that this is proportion. And they will tell you success is sample size. Okay, we already know that 90 is the successes, sample size is 1,600. And if you switch them, Desmos is going to put it in red and not going to let you get away with it. So we're going to click on create test. We got the test, and this time we're doing significance test. And look right here, you've got your P. So hopefully you will understand that that's P and not P hat or anything else. The null hypothesis always has equal sign, which is what it says right here. Now the alternative. That has to match the claim. The claim said, and it says it right here, whether the percentage of students who major in education has declined. So decline is your clue word. That means less. You have a left tail test. So here we're going to select left, and here we're going to say less. Okay, what do I put in here? That's another thing. Do not ever put anything that comes from the sample into the null or alternative. This should be a value that is already known before you started collecting sample, which is 8%. Try to put 8 in here and see what happens. If I put 8, what's wrong? Desmos says undefined. Well, no wonder, because proportion is a number between 0 and 1, and you cannot put 8. You have to convert 8 to a decimal by dividing by 100. And it's not 8, it's 0.08. And also 8% is not 0.8, it's 0.08. Okay, so with that said, let's put that here. And we are good to go, except we have to check assumptions. Okay. Before we do that, let's fill out the test statistic and the p-value. So I'm going to delete this. And they give me the p-value and the test statistic is on the graph. But if I need more decimals like 4, I can look at them if I click on the 3 dots. And I got negative 3.5018 for the test statistic. In absolute value, this is more than 3. And that's definitely an outlier. So probably we are going to reject, but we're going to see that in a second. P-value is very small. That's another reason that definitely going to be unusual. We will reject. In fact, I can say that right now. It's less than alpha. We are rejecting, which means we have evidence to conclude that the proportion of graduates with education has declined. Match the claim. Okay, so the only thing that we need to do is check assumptions. The assumptions say, and hopefully again you will have this on your note cards, that n p0, 1 minus p0, that number should be greater than 10. Okay, so be careful. The assumptions here are not the same as for the confidence interval where we had n p hat, 1 minus p hat. We're not using p hat, which is that x over n number that we computed like this one. No, that's not what we use. Okay, so let's see. First, n. N is the total number of trials, total number of people in the sample, 1600. So we'll start with that. Multiplied by p0. Not p hat. P0 is the number from the null hypothesis. That's 0.08. And then we multiply that by 1 minus 0.08. Okay, our answer here is going to be 117.8 if we round to one decimal place. Is that larger than 10? Of course it is, which means that the assumptions are satisfied. Let's check our work.